SpaceX, Elon Musk's space exploration company, is the first commercial company capable of carrying people into low Earth orbit. Besides the fact that Elon has led them to achieve previously unthinkable feats, the first stage of their Falcon 9 rocket, for example, can be launched, landed, and reused multiple times. Welcome back to another exciting video. Today's video is about Elon Musk hinting at a commercial space station by 2035. Before we start the video, please like, subscribe, and press the bell icon. Let's look at one project that SpaceX can complete in the future. Simply put, that appears to be either impossible or exceedingly unlikely at the time. A space station in low Earth orbit with artificial gravity generated by centrifugal forces is expected to be completed around 2035. This episode will not go over the reasons why Elon Musk could want such a station or why he might not want such a station. This thought experiment is being carried out solely to determine whether or not it falls within the realm of possibility and the scope of SpaceX's future capabilities. Fortunately, Elon Musk and his SpaceX team are working around the clock on the first issue. SpaceX expects to have its Starship cargo tanker type operational by 2025. The crew of the Starship will after that follow. Starship cargo will initially be capable of transporting 100 metric tons to low Earth orbit, with the capability of transporting 150 metric tons after Starship is fully optimized, which is expected to happen between 1 and 2 years after the first operational version of Starship has flown. As a result, the station's initial components may be brought up to LEO by 2026. Which would be the starting place for building. On the other hand, let us stay within the bounds of ourselves, especially since Elon's strategy is unlikely to be this. Let us detail the many phases crucial to bringing such a project to fruition. The first phase in any large-scale construction project is research and development, R&D. This step often comes after a significant amount of time has elapsed, regardless of whether it is being carried out on Earth or beyond, because several technologies and materials must be tested before being permitted for use in the construction phase. Suppose this procedure is carried out in collaboration with existing corporations and organizations, such as NASA. In that case, it is feasible that the pooling of skills and knowledge will speed it up. However, under this scenario, SpaceX is collaborating with NASA and other nations and commercial organizations to make this mission a reality, to be completed over 2 to 3 years. The assembly of the station's components. When the R&D and design phases are finished, SpaceX has probably already mainly built automated manufacturing lines for the space station's numerous details. Radiation shield panels, structural beams, windows, thermal insulation plates, water oxygen tanks, interior walls, and many other components must all be built in large quantities. Elon Musk has the expertise and abilities to make such a production line. He may even contemplate using the Tesla facility for this purpose, altering the robotics and retraining the workforce as soon as the production lines for the individual components have been optimized. It would take 4 to 6 months to complete all the building parts, examine them, and approve them. According to this preliminary calculation, transporting the empty bulk into low Earth orbit would take around 300 Starship freight flights. In 2024, manufacturing more than 1 Raptor engine per day will allow the construction of 10 Starships and Super Heavy boosters in the same year. Daily, the Raptor engine plant can produce more than 11 Raptor engines. This equates to 4,000 units per year. This is enough to equip 100 Starships and Super Heavy boosters with their respective engines. Orbital construction. To use the pre-manufactured parts and build the station we want, the station will require an orbital assembly platform in LEO. There is no requirement that the orbital assembly station be huge. Simply put, it is a platform that allows Starship freight to dock and unload components, which are retrieved by robotic arms and set to where they will be assembled. An assembly ring the same size as the habitat ring will likely be erected. This assembly ring would serve as a platform for installing and moving robotic arms with various mechanical and welding tools. Human technicians on Earth might exercise control of these robotic arms. One proposed application for the SpaceX Starlink satellite network would be to provide a low-latency, high-bandwidth connection between the ground station and the assembly station. This would enable personnel on Earth to control the robotic arms and equipment as if they were in space. All they'd have to do is put on virtual reality glasses that provide a 360-degree view of the scene. This remote operation method will result in significant cost savings and a tenfold increase in the pace of orbital assembly because more remote technicians can operate concurrently and go operational. Once the station's components have been fully built, it will still require many further Starship freight missions to make it operational. Hundreds of journeys would be required to provide it with water and the ingredients needed to manufacture oxygen. It would also need fuel to change its orbit due to the atmosphere's drag. Before the arrival of humans ready to test the artificial gravity, a reasonably sized orbital farm that can feed the stations with much sought fruits and veggies, as well as everyday things like beds, utensils, food supplies, and the ingredients to do so, must be constructed. Even the most miniature livestock can be raised. As for chickens and other such animals, we can only hope that the head of a chicken does not continue to try to arrange itself in line with the gravity of the Earth, because it would be highly unusual to see. The next question is how much this could cost. Construction costs estimated. Trying to predict the costs of building this orbital behemoth is akin to attempting to count the number of planets in our galaxy capable of hosting life. We can provide an estimate, but it will probably be significantly off. Nonetheless, a reasonable estimate of the total expenditures involved with the construction project exists. An assessment of 1,000 Starship freight missions would be required to assess the launch costs. If each launch costs between $2 and $5 million, this would amount to over $4 billion. Over time, the research and development phase necessitates the participation of highly qualified and expensive personnel. As a result, the costs connected with this phase will be between $7 and $10 billion. This could be minimized if sophisticated artificial intelligence and machine learning are used for material testing, simulation, and other uses. The price of creating the manufacturing line and other orbital assembly platforms is expected to range between $2 and $3 billion. In addition, the manufacturing plant will be placed in space. Resources and materials. The combined cost of the raw building materials for the central station and the material resources necessary to make it operational is expected to be in the $5 billion range. In summary, it is predicted that $18 to $20 billion will be spent. Given what we know about the costs of space travel, this figure is absurd. The International Space Station, ISS, cost $150 billion to build and launch. The cost of such a station would be 100 times that of the ISS. However, because SpaceX will be in charge of this future endeavor, we must examine the costs of space transportation and development through Elon Musk's eyes. It's worth noting that SpaceX successfully launched its first rocket into space in September of 2008. The Starship's payload will likely be successfully launched in 2025. That is a 17-year gap during which the company completed engineering feats previously thought impossible. Given that technological improvement is occurring almost exponentially, SpaceX should create such a space station in outer space, the source of funding. Assuming that the project's total cost is roughly $20 billion, the question is where SpaceX will acquire the money. This station has a capacity of roughly 1,000 people at any given time. Between 300 to 500 seats can be set out entirely for space tourism. Assuming each person pays around $1 million for a one-week stay, tourism earnings would total approximately $500 million in a single week. Google estimates that there are approximately 36 million millionaires on the Earth. A few of these people would have the financial means and inclination to take the most opulent vacation conceivable away from Earth. It is still being determined whether we will ever have the opportunity to view such massive space buildings in our lifetimes. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.